find the mean? Anybody remember how to find the mean of numbers?
You add them all up.
Add them all up. And then what?
Divide by how many numbers.
So go ahead and do it. All right, so when you add them all up, what did you get? 100. Who got 100? All right. So when we add them all up, we got 100, and then we had to divide it by what? What did you divide it by? 10, because there are 10 numbers. And what is 100 divided by 10? 10. Good. That is your mean. The symbol in math is an X with a line across it. That's what we call it in stats. That means mean, by the way. Okay, y'all. So today we're going to learn how to add and subtract radicals. Okay. So we already did multiplying and simplifying. So now we're going to go to addition. So go to page 13. So in this box, it talks about adding and subtracting radicals. And it's a little bit different. In order to add or subtract, the radicals must be like terms. I'm going to actually underline that, okay? And they're only like terms if they have the same index and radicand, which is a really fancy math word. But radicand is just the number under the radical. So that's what that is. So if you have the same number under the radical, then they are like terms. Same number under the radical, and they're like terms. Okay. And when it says same index, what that means is you can't add a square root. So you can't do the square root of 2. I mean, the cube root of 2 plus the square root of 2. That doesn't work. Okay. Because they have to they have to have the same number in the elbow. Index is the number in the elbow. Okay. So that's what it's saying. And you can't add together the square root of 3 plus the square root of 2 because they have different radicands. Okay, so they have to have same number in the elbow, that's what we call the index, and the same number under the roof, which is our radicand. So let's go ahead and hit it. We're going to do 7 today, and then we'll do the other half tomorrow. All right, so let's look at A. Notice that they're both square roots, right? Because you don't see a number in the elbow, that means they're both square roots. And then the number under the radical for both of them is a 3. So that means that these are like terms. So these are like terms. So what we're going to do, there is an invisible number right here. We're going to add the number in front. That's the coefficient. So we're going to do 1 plus 5. 1 plus 5 is 6. But we do not add what's under the radical. That stays the same. So our answer is 6 square root of 3. Now, before you add, you do want to make sure that you can't simplify it. So when I'm looking at B, notice that, first of all, we know this cannot be simplified because 2 is one of the numbers that I build a cake with, right? But that 8 can be simplified. So what I want you to do, build your cake with the 8. Remember, when you're building a cake, you're just dividing by 2, 3, 5, and 7. That's what you're going to divide by. 2, 3, 5, and 7. So go ahead, keep dividing 8 until you get the one at the top, till you get your candle. And the numbers we divide by are 2, 3, 5, 7. And most of the time, we don't even get to 7. It's just 2, 3, and 5. So if you see a question where there's already a 2, a 3, or 5 underneath the radical, you know you're done. You can't do anything with that. All right, but this 8, we can. So 2 goes into 8 4 times. 2 goes into 4 2 times. And 2 goes into 2 1 time. So we're looking for pairs because the index is 2. So I do have a pair. I have 1 pair of 2s. So that pair of 2s can come out. But this one right here did not have a friend, so it has to stay. All right, so I'm going to bring down what I had in front. This is what was already there. Now, they didn't start off like terms. But can you all see that they really are like terms? Because what do they both have under the roof? A 2. They both have the same number. So that means that I can add the 4 and the 2 together. 4 plus 2 is 6. But again, do not change the number underneath. We do not add that. We can multiply those numbers, but we cannot add those numbers. That would be your final answer. I know, it's a struggle. All right, let's look at C. All right, this one already has a 5, so this tells me that this is done. Can't do anything with that. I'm just going to bring it down. But that 20, we can do something with that 20. So let's go ahead and build our cake with the 20. Keep dividing it until you get your candle at the top. All right, so does everyone see there? What do we have a pair of? What can we take out? A 2. We got a pair of 2s that can come out. But then that 5 has to stay. So are these like terms? Who says yes? Who says no? Who's not sure? They both have a 5 and a 5. So that means we can. So you're going to just do a 3 minus 2. 3 minus 2. 3 minus 2 would be a 1. So my answer is 1 square root of 5. But anytime the number in front is a 1, we don't have to put it. You can also just put a square root of 5. Both of those are right answers. Any questions? All right, good work, y'all. Let's keep going. Let's look at D. So 6, when we build a cake with the 6, if I divide it by 2, then I divide it by 3, I want you to notice that we don't get a pair, right? A 6 has a 2 and a 3, but we don't have a pair of anything. So this is actually simplified. We can't do anything with that. I'm just going to bring it down. All right, but this 24, we can do something with. So go ahead and build your cake with the 24. So we got a 2, another 2, another 2. Okay, so we have a pair of 2s that can come out. Now underneath, I have 2 numbers. I have a 3 and a 2, and they're not pairs. So we would multiply those together. So if you don't have a pair, whatever we have just comes out and we multiply it. And when we do that, we end up with square root of 6 plus 2 square root of 6. So are these like terms? Who says yes? Who says no? All right, they are like terms because they both have a 6. They both have a 6 under the roof. So we can add it together. This has an invisible 1. So I'm adding together 1 plus 2, and that gives me 3. That would be my answer. All right, let me just do a little temperature check. How we feeling? Thumbs up, sideways, down. Just everybody, I'm just looking at you. I'm just trying to see how do we feel. All right, no thumbs down. That's all I'm trying to say. So sideways is okay because this is something brand new. So that's okay. So we already know from example D that 6 cannot be broken down. So I'm just going to bring this term down. All right, I'm going to bring down my subtraction sign, and I'm going to bring that 7 down. All right, then I'm going to stop there. With that 54, I want you to build a cake. All right, so this is my cake. All right, what do I have a pair of? What can I take out? A 3, good job. So I'm gonna take out this 3. This 3 is gonna come out with the 7. That's gonna come out with the 7, right behind the 7. And then when I make my radical, again, I have 2 numbers that didn't have a twin. So I have a 2 times 3 underneath. All right, so this is 2 square root of 6 minus, let's go ahead and multiply these together. What do you get when you take 7 times 3? 7 times 3. So anytime you take something out and there's already something there, we have to multiply it together to get a new front number. Okay, 7 times 3 would be 21. And then underneath, I have 2 times 3, which is 6. Are these like terms? Do they have the same number under the hood? Yes, they both have a 6. So because they both have 6, we can do whatever operation is asking us to do with the numbers in front. And what they want us to do is take 2 minus 21. 2 minus 21. And 2 minus 21 would be negative 19 square root of 6. All right, so I want you to do F by yourself. I'm just going to peek over your shoulder. Not going to say nothing. So I want everyone to try to do F. Then we'll come back together and go through it together. No judgment. I just want to look and see how far we get. Johan, you okay? We doing F. We got F and G, and then I'm done. Go ahead, lock on in with me. All right, let's see how we did. That was pretty good, though. Nobody froze. We all at least build our cake. So that's promising. All right, so with this 12, we can build our cake. I'm going to build it over here, actually. So I'm going to divide it by 2. I get a 6. I divide that 6 by 2. I get a 3. I divide that 3 by 3. I get a 1. So whose cake look like my cake? All right. So now notice that we already had a negative 2. That negative 2 is still there. So I'm just bringing down that negative 2. But I'm adding to it another 2. I'm going to just bring out with it. And then when I make my square root, underneath, I have this 3. So this one is already simplified, so I'm just going to bring that down. Nothing changes with that. So anytime you have more than one number in the front, you're multiplying these together to get the new number. So when you take negative 2 times 2, you get negative 4 square root of 3. And then this one doesn't change. They are like terms because they both have the 3. So we're just going to use our calculator and add negative 4 plus 3. And then your final answer would be a negative 1 root 3. Or you could just drop the 1 and put a negative root 3. All right, try to do G by yourself. Last one. wasn't bad. That was actually really good. Really good, I will say. Okay, so let's look at G. So in G, the first one is done. Can't do anything with that. Okay, the 20 can be simplified. So I'm going to build my cake with the 20. So first I'm going to divide it by 2. That gives me 10. I'm going to divide that by 2 again. That gives me 5. I'm going to divide that by 5. Okay, only because this one already had a number in front, that number doesn't go away. We can't just erase it. It's there. But we're adding to that another 2. So what I get now in front is 2 times 2. And I have the square root of 5. So we have 4 square root of 5 plus, what is 2 times 2? 4 square root of 5. So when I add them together, because they are like terms, they both have a 5. When I add them together, I'm adding 4 plus 4, and your final answer would be 8 square root of 5. All right, any questions about today's lesson? I always ask. Nobody ever has questions, though. It's very weird. All right, so just a reminder, homework 2 is due on Friday. Now, you should have the majority of homework 2 finished, except for 5, 6, 10. Okay, so 5, 6, 9, 10, 11. Now, you can work on 10 and 11 and 9, but we're going to really focus on that tomorrow. All right, so what I want you all to do now, though,